Okay, ladies and gentlemen, this is Unit 5, Notes 5. It is the last unit for quadratics. So, of course, it is quadratic applications, and applications mean word problems. Dun, dun, dun. The math students' kryptonite, word problems. So, what you need to be able to do is look at a word problem, read it, and figure out how to set up and use the quadratic formula to help you solve it. So, that is kind of what you're looking at here. So the height h of an object t seconds after it is propelled upward with initial velocity v is represented by h equals negative 1/2 gt squared plus vt plus h, where g is the gravitational pull and h is the initial height. So just kind of looking at this, just kind of look at this big equation. This is however far off the ground something is at a given time when it's in flight. So if I throw a baseball up in the air, this is going to be how high it is off the ground at a given time, okay? So after 1 second, here's the height. After 2 seconds, here's the height. After 4 seconds, here's the height. All right, after 7 seconds, it's probably going to be on the ground because you can't throw a ball in the air for 7 seconds. G is gravity. Pretty straightforward. V is your velocity. Basically, that's how hard do I throw the ball up in the air. And H is where does it start in the air. So if I throw the baseball and I let it go at 6 feet in the air, H would be 6. All right. If I let it go, if I throw it straight up and I let it go at 8 feet or 9 feet, H will be 9. Okay. So suppose an astronaut on the moon throws a baseball upward with an initial velocity of 10 meters per second, letting go of the ball 2 meters above the ground. Gravity on the moon is 1.6. So here's what that looks like. Just playing fill in the blank. That looks like this. Initial velocity, no, you don't need an equal sign yet. The initial velocity was 10 meters per second, and the moon, and the initial release point was 2 meters off the ground. So I can multiply this to become negative 0.8 t squared plus 10t plus 2. So suppose the gravity on the moon. So that is what that would look like. So say someone threw the ball from the same height and the same velocity on Earth, where the gravity constant is 9.8. So on the moon, the gravity is 1.6. On Earth, it is 9.8. That's why you're a lot lighter on the moon than you are on Earth. P squared plus 10t plus 2. So when I do that, that's going to be negative 4.9 t squared plus 10t plus 2. All right. So that is that's gravity. That's the middle one, 10t. That's how hard you throw the ball, and 2 is your where you release it in there. So the big idea here is looking at these two. Where's the ball going to go farther and longer, on the moon or on Earth? Well, the answer is going to be the moon because gravity is a lot less effective up there. All right, a projectile is shot vertically up in the air from ground level. Its distance s in feet after t seconds is given by s equals 96t and minus 16t squared. Find the value of t when s is at 96 feet. All right, so we take this thing, shoot it way up in the air, and it comes back down. Why? Because what goes up must come down. So what we're trying to figure out is this thing that goes up in the air and comes back down looks like a parabola, but we're saying that, you know what, it goes past 96 feet. We're trying to figure out, and it's going to pass through 96 feet twice. How long does it take to get to 96 feet, and how long before it comes back down to 96 feet? That's kind of what we're asking. So this might be a rocket, arrow, what have you. How long does it take to get up to 96 feet, and then how long does it take to come back down to 96 feet? So I'm going to take this equation, and I'm going to set it equal to 96. So like that. So now here's what I'm going to do. I'm going to rearrange everything, and I'm going to get everything over onto one side. So here's what this is going to look like. Follow me here. And so it looks like that. So why did I do that? I did that because it's equal to 0. Now I can work with this and do the quadratic formula. Now, here's kind of what's interesting. Between 1696 and 96, there is something in common. All right? So all three of these can be divided by 16. So that's what I'm going to do. I'm actually going to divide everything by negative 16. All right? Perfectly legal. I'm dividing by both sides by the same thing. So here's what it looks like. 0 divided by negative 16 is still 0. On the right side, when I do this, it becomes every piece gets divided by negative 16. This should be a minus. Yeah, that's a minus over negative 16. So simplify, that becomes t squared. This becomes minus 6t. This becomes plus 6. Now, be honest. You tell me which looks easier, this one or this one. I think the second one looks a lot easier. So I want to deal with that. So I'm going to do the quadratic formula on this. So that's going to be a is 1, b is negative 6, c is 6. So that's going to be 6, positive 6, plus or minus square root of negative 6 squared, which will be positive 36, not negative 36, times 4 times 1 times 6, all over 2 times 1. So what that becomes is 6 plus or minus square root of 36 minus 24 all over 2. So that's 6 plus or minus square root of 12 over 2. Now, here, where they're looking for a pretty exact time. They're saying, you know, how long does it take to get to 96 feet? How long does it take to get back down? So this, while this answer works mathematically, it doesn't work really well for the context of the problem. So I'm going to put that into my calculator and see what I get. So 6 minus square root of 12 divided by 2 is going to be 1.26795 seconds. So when I initially shoot it up, it's going to take approximately 1.2 seconds to get to 96 feet. Then when I do that again, 6 plus the square root of 12 divided by 2, my other answer is going to be 4.732 seconds. So this part right here is 1.27 seconds, or 267 seconds. This part right here is 4.732 seconds. All right, so I think this is one of the last ones. Pan is formed by cutting 2 centimeter by 2 centimeter squares from each corner of the square sheet metal and then folding up the sides. If the volume of the pan is going to be 441, what should the dimensions of the original piece of sheet metal be? So, for those of you guys that forget, volume is going to be length times width times height. Okay, so the height of this thing is going to be 2. This is going to be x minus 4. Okay, so this whole thing is x. This whole thing is going to be square, so it's going to be x minus 4 times x minus 4. What they want to know is how long should this piece be? Okay, so how long should this big square piece be so they can cut it down and around? So what I need to do is figure out what is x going to be when it's all got to equal 441. So volume is going to be length times width times height. This is x minus 4. This is that same length. So I'm going to have x minus 4 times x minus 4 times 2. All that's got to equal 441. So now this side, this left side becomes FOIL. First, outside, inside, last. Remember, you're happy to do this. So x squared minus 8x plus 16 times 2 equals 441. So that's 2x squared minus 16x plus 32 equals 441. So now subtract 441. Why? Because this makes it equal to 0, and that means I can take the quadratic formula and throw everything in there. So this is A, B, and C. So a quadratic formula becomes positive 16 plus or minus 16 squared minus 4 times 2 times negative 409 all over 2 times 2. Now, here's what's interesting. You're probably going to get one weird answer and one okay answer. So 16 squared plus 4 times 2 times 409 equals square root of 3528 all over 4. So the square root of this thing is about 59.397. So 16 plus or minus 59.397 over 4. So now use a little logic here. If I do 16 plus 16 minus, that's what the math says to do. But is that what logic says to do? Well, if I take 16 minus a negative number, 16 minus 59, I'm going to get a negative number. Take that divided by 4, it's still going to be a negative number. There's absolutely no way my length can be a negative number. So this one, don't do that. So take your positive answer, and x is going to be equal to 18.85. So that is how big this original piece of sheet metal should be. It should be a square that is 18.85 times 18.85. All right, so last problem. Jimmy John's tracking the sale of a sub. The manager sees that the quadratic representing this is y equals negative 25x squared plus 250x plus 400. Find the vertex and the axis of symmetry and what is the maximum revenue. So this is one, vertex axis of symmetry. This is one where you don't use quadratic formula. This is where if I'm looking at the graph, this is my vertex, this is my axis of symmetry. I don't use quadratic formula because quadratic formula gives me these. I don't want those, I want this. So this is where I need to take negative b over 2 times a and then put that into the function. Okay, so negative b would be like negative 250 over 2 times negative 25. So what is that? Negative 250 or 250 divided by 50, which for those of you scoring at home is 5. So now that is your axis of symmetry. To figure out your vertex, put 5 back in exactly for x. So negative 25 times 5 squared plus 250 times 5 plus 400. So 25 times 25, this is going to be negative 625. 250 times 5 is going to be 1250 plus 400. So negative 625 plus 1250 plus 400. So that's going to be 1,025. So the maximum revenue is what you get for your answer. So that's going to be $1,025. Okay, word problems. Go, attack them, be successful, break things down, take things apart, and put them back together the right way.